My topic is HEERNLP, Hierarchical Energy Efficient Reactive Network Layer Protocol for WSN. The content of this are abstract introduction related work, the main protocol, conclusion and future scope, and then references. The first is the abstract. Wireless sensor networks are gaining a lot of attention by the researchers from worldwide due to its application capacities expanded day by day. WSN are formerly were tiny wireless sensor nodes, which are a type of tiny computing devices with resource constraint in nature. The objective of this research contribution is to present a glance of an extended version of an energy efficient reactive network layer protocol for WSN titled HEERNLP, which will be fruitful for large number of densely deployed environments. Next one is the introduction. In WSN, performing measurement and sending data may be crucial at arbitrary times. These two tasks contain no big potential to save energy except for data aggregation and compression. After analyzing resource footprint, it has been observed that routing complexity in WSN will increase with the increase in number of wireless sensor nodes. By keeping above mentioned observation in mind, it is evident that there is a need to consider beyond traditional routing approaches, and hence base station controlled routing protocol can be a better option, which is our current area of study. Next is the related work. The WSN is a special class of infrastructure less networks that it has to provide all the services it needs itself. In WSN, each node has dual responsibility. It acts as a source of information or work as a router for other nodes. The next point is, and due to deployment in remote, antagonistic and unattended environments, it is very vital to design algorithm and protocol for sensor nodes that operate on minimal energy, which can be achieved by reduced communication between source nodes, a bridge computation, and using lightweight security solution. These are the classification of my related work. The classification is on the energy efficient aware routing protocol is also available. It is classified on the 2 points, energy manager and energy saver. Energy manager protocol balance energy consumption in network to avoid network partitioning, while energy saver protocol decrease energy consumption totally because most of them try to find the shortest path between source and destination to reduce energy consumption. Some of these energy efficiencies are heat, beer, teen, aptene, H-heat, and others. The next is the HEERNLP, that is the hierarchical EERNLP. This protocol is an extended version of an energy efficient reactive network layer protocol for WSN. The objective of this is quite simple: remove route finding burden from a tiny sensor node and hand over to the base station, which is more powerful in terms of computational resources. In case of EERNLP, wireless sensor nodes energy has been retained, saved by removing route finding burden from node to base station. The EERNLP is reactive in nature because it searches route or nodes demand for sending application data. This is an abstract view. This is the region of interest or sensor field. This is the node sensing range, node transmission range, gateway nodes, wireless sensor nodes, downstream traffic, upstream traffic. These represent the base station, sync nodes, antenna or satellite. These are the base station is connected to the internet or satellites, remote access nodes. HEERNLP will be fruitful for a large number of densely deployed environments such as follows: the base station, which is available at the level N, and the tiny nodes or the sensor devices, which is available at the level 1. These can communicate their path to the level 2. The level 2 again communicate their path to level 3, and so on, and it reaches to the base station. The base station resolves the path and send back to the sensor nodes, that is through n-1, n-2, 3, 2 and 1. These are the region of interest. This is the gateway. All sensor nodes are connected to the gateway, and the gateway is indirectly connected to the base station. Next, the advantages. Simultaneous traffic flows is possible between node to gateway nodes and gateway nodes to base station. Network monitoring and dynamic programming solutions are available. It is possible that routing data can be updated from the base station when essential. The steps involved here are all sensor nodes switch their receiver on, including gateway nodes as well. The base station represents each region of interest by a 2D matrix. The base station also fetches the information how to reach a particular region of interest through gateway nodes at various levels. The base station uses binary value 0, 1 to fill 2D matrix for each region of interest based upon health information of nodes. Binary 1 denotes a live or working node. Binary value 0 represents all other cases such as there is no node or dead node. These are the other steps like base station broadcast individual region of interest describing the current health of WSN nodes to all nodes of the region of interest, and 1D matrix containing path from sensing nodes to a very close gateway. Each sensor node holds a recent copy of the both 2D matrix and 1D matrix. An updated 2D matrix must be immediately broadcasted by the base station to each region of interest. Respective nodes at all times. If some events related to nodes health are occur, such as new node is added, any node dies in that region of interest. If any node wants to send data to base station, node first scan that 1D matrix for the route and find the next node. Conclusion and futures. So the present contribution first highlights the importance of energy efficiency and awareness of the term of WSN protocol. The proposed scheme is little straightforward, but it is clean slate routing scheme and required more exploration with comparison and performance evaluation. It is a great advantage of HEERNLP since its approach is more realistic, effective, and evolutionary in field of WSN. This enhances the belief that HEERNLP is indeed capable of being implemented on real modes and performance evaluation in a testbed environment in future. These are some references. Thank you.